This resource is the first in a two-part series on methods for solving quadratic equations. Part 1 defines quadratic equations. We then look at a general solving algorithm, supposing that the quadratic can be factored. We look at multiple examples. Part 2 considers the generic solution method for quadratic equations, the quadratic formula. The formula is presented. Then we consider multiple examples, including an application problem. Quadratic equations have a squared term as the highest power. The general form is identical to that for a quadratic polynomial, set equal to 0. There are a number of different ways to solve a quadratic equation, but we will focus on solving by factoring in this resource. This method works only when the quadratic itself can be factored. But how exactly can we solve by factoring? First, we need to have all the terms on one side of the equal sign and a 0 on the other side. Then we factor the quadratic. Now we will have a product equal to 0. This implies that one of our factors is equal to 0 themselves. So we can split the equation into two separate, smaller equations. We solve those simpler equations. Let's look at some examples. Suppose we have the equation x squared minus 13x plus 36 equal to 0. Note that we already have all our information on one side of the equal sign. We can proceed to factoring the quadratic. Recall that we want factors of positive 36 that add to negative 13. After we factor, we have x minus 4 times x minus 9 equal to 0. We split the two factors into separate equations. We have x minus 4 equals 0 or x minus 9 equals 0. To solve the first equation, we add 4 to both sides. Add 9 to both sides to solve the second equation. So our solutions are x equals 4 or x equals 9. Note that we got two separate answers. In mathematics, we may get as many distinct solutions as the highest exponent in the equation. Since we had a squared term, we got two different answers. Let's look at another example. Let's say we have x times the quantity x minus 3 equal to 40. We start by distributing the x through the parentheses to get x squared minus 3x equal to 40. Because we want 0 on one side of the equation, we subtract 40 from both sides. This leaves the equation x squared minus 3x minus 40 equal to 0. We factored this quadratic as x plus 5 and x minus 8. Split the factors into separate equations. Subtract 5 from both sides to solve the first equation. Add 8 to both sides to solve the other equation. We have x equals negative 5 or x equals 8. What if our quadratic has a leading coefficient that is not 1? Suppose we have 2x squared minus 9x minus 5 equals 0. This quadratic is harder to factor. After some guessing and checking, we find the correct factors as 2x plus 1 and x minus 5. Split the factors into separate equations. Now we work to solve each equation. The second equation is simple to solve. Just add 5 to both sides of the equation. The first equation requires a couple of steps to solve. First, we subtract 1 from both sides. This leaves us with 2x equals negative 1 from the first equation, and our solution of x equals 5 for the second equation. We need to divide both sides of the first equation by 2 in order to solve. This gives us the solution x equals negative 1/2, along with the other solution x equals 5 that we found previously. The distinguishing feature of a quadratic equation is that the highest order variable term is a squared. To solve by factoring, move all the information to one side of the equal sign. So you have something of the form ax squared plus bx plus c equal to 0. Factor the quadratic. Split those factors into separate equations, which you then solve. All quadratics can be solved, even though not all quadratics can be factored. So how can we solve these non-factorable quadratic equations? Stay tuned for part 2.